Chapter 5.3, the tangent ratio. The value of the tangent of an angle theta is equal to the slope of the terminal arm. A point on the unit circle can be written as xy or cos theta sine theta. So tan theta equals y over x, which equals sine theta over cos theta, which equals rise over run. Let's draw a diagram to represent this. If we have an angle theta, theta is here. You can draw a right triangle by going straight down to the x-axis. Then the opposite side is y value, and the adjacent side is the x value, and our hypotenuse is the radius. Tan theta equals opposite over adjacent, which is y over x. And in terms of slope, y would be the rise, and x would be the run. So tan theta equals rise over run. Characteristics of the tangent function. The tangent function curve is not continuous, unlike the sine and cosine curves, which are continuous. Is there a max or min? No, there is not a max or min, unlike the sine and cosine functions. The tangent function has vertical asymptotes. Let's look at the unit circle to see why this is the case. At an angle of 0, the point on the unit circle is 1, 0. Then tan of 0 degrees or 0 radians is 0 divided by 1, which equals 0. At 90 degrees or pi over 2 radians, we have the point 0, 1. Then tan of pi over 2 would equal the y value divided by the x value, 1 divided by 0. But this is undefined since we can't divide by 0. So that causes a vertical asymptote. Then at pi, we have the point -1, 0, so tan pi equals 0 divide -1, which is 0. And then at 3 pi over 2, we have the point 0, -1, and tan of 3 pi over 2 would equal -1 divided by 0, which again is undefined. So it creates a vertical asymptote. So our vertical asymptotes would be at pi over 2, and then pi over 2 plus pi, and then pi over 2 plus 2 pi, pi over 2 plus 3 pi, etc. So we have pi, 3 pi over 2, and continuing in that order. If we write this in general form, we would have pi over 2 plus pi n, where n is an element of the integers. When does tan theta equal to 0? We just saw that as well. That started at 0 and pi, 2 pi, etc. So 0 plus pi n, where n is an element of the integers, or just pi n, where n is the element of the integers. When is tan theta equal to 1? Remember, tan is y over x, so when y equals x, when does that happen? That's at reference angles of 45 degrees, but in certain quadrants. So x and y have the same sign in quadrant 1, they're both positive, and in quadrant 3, they're both negative. The other quadrants, one's positive, one's negative. So only in quadrants 1 and 3, which would mean we would have pi over 4 in quadrant 1, and then we would add pi to get 5 pi over 4, add another pi to get 9 pi over 4, etc. Then in general, we have tan theta is equal to 1 at pi over 4 plus pi n, where n is an element of the integers. Tan theta equals to 1 when y equals negative x. So when we have the same number but opposite signs for y and x, that happens at a reference angle of pi over 4, but in the other quadrants. So we have quadrant 2 is negative and then positive, and quadrant 4 is positive and then negative. So in those two quadrants, which would be 3 pi over 4, and then add pi to that would give us 7 pi over 4, add pi to that would give us 11 pi over 4, etc. In general, that would be 3 pi over 4 plus pi n, where n is an element of the integers. The domain of the tan function is related to our vertical asymptotes. The function is defined anywhere except where we have vertical asymptotes. Then we can use that general statement, how we wrote the vertical asymptotes, in our domain. So x or theta, such that theta cannot equal pi over 2 plus pi n, where n is an element of the integers, and theta er. The range for tan theta is just y, such that y-er. The theta intercepts, or the x-intercepts, when was tan theta equal to 0? We saw in our unit circle that that happened at theta equals to 0 and also theta equals to pi. So at 0, pi, 2 pi, etc. Then the general form would be 0 plus pi n, where n is an element of I, or just pi n, where n is an element of I. And then the y-intercept, when theta equals to 0, tan theta equals 0. So our y-intercept is 0, 0. And here we have the graph of the tan function. We've got our vertical asymptotes at pi over 2, 3 pi over 2, also at negative pi over 2, negative 3 pi over 2, and so on. We have that tan theta equals 1 at pi over 4, 5 pi over 4, or the negative is negative 3 pi over 4, negative 7 pi over 4, etc. We have that tan theta equals negative 1 at 3 pi over 4, 7 pi over 4. In the negative direction, it would be negative pi over 4 and negative 5 pi over 4, etc. Our domain is all values except the vertical asymptotes. Our range is everything. This is continuing to negative infinity, and this is continuing up to infinity. Our theta intercepts happen at 0, pi, 2 pi, negative 2 pi, etc. And our y-intercept is at 0, 0. I just noticed a couple errors in my notes here. So for the vertical asymptotes here, this should be pi over 2. I believe I said pi over 2, but I didn't write pi over 2. And then same for our domain here. I said one thing and wrote another. This should be theta cannot equal pi over 2. So not equal to pi over 2 plus pi n, where n is an element of the integers, because that represents all the values of our asymptotes, which is the only values that our theta is not defined. Graph y equals tan theta for 0 degrees is less than or equal to theta is less than or equal to 360 degrees. I'm going to start by drawing a unit circle. At 0 degrees, we have the point 1, 0, which gives us tan theta equals 0, 0 divided by 1. Then at 45 degrees, we have the point root 2 over 2, root 2 over 2. Then tan theta would equal 1. At 90 degrees, we have the point 0, 1, which gives us tan theta is undefined, because we would have 1 divided by 0. At 135 degrees, we have the point negative root 2 over 2 and positive root 2 over 2. Same number but opposite sign would give us tan theta equals negative 1. Then at 180 degrees, we have the point negative 1, 0, which gives us tan theta is 0, 0 divided by negative 1. At 225 degrees, we've got the point negative root 2 over 2, negative root 2 over 2. So tan theta equals 1. At 270 degrees, we have the point 0, negative 1, and tan theta is undefined. And then at 315 degrees, we have the point root 2 over 2, negative root 2 over 2, which gives us tan theta is negative 1. Now we can plot this information on our graph. We're going from 0 to 180 in 1, 2, 3, 4, 5, 6 steps. So divide 180 by 6, we get 30. So our scale is 30, 30, 60. I'm going to put 90 here, 180, and then halfway between 180 and 360, I'll put 270. I'm not going to label them all because it'll be too cramped. Let's start by drawing our asymptotes, which occur at 90 degrees and at 270 degrees. Next, let's plot our X-Intercepts. Those happen at 0 degrees and at 180 degrees. 0 degrees, 180, and then again when we get back to 0, which would now be 360. Then let's plot the points where tan theta equals positive 1, which are at 45 degrees and at 225 degrees. 45 degrees is halfway between 0 and 90, so it'll be right here, and positive 1 is up there. Then also at 225, so halfway between 180 and 270, go up to y equals 1. And then last we can graph the points where tan theta equals -1, which we're at 135 degrees and also at 315 degrees. That would be 135 is halfway between 90 and 180, go down to -1 at that point, and then halfway between 270 and 360, go down to -1 at that point. Then we just join the points together with a bit of a curve. It kind of flattens out at the X-intercept. And it just continues on forever. And then we do the same here. And here. And there's y equals tan theta for theta between 0 and 360 degrees. Problems using tangent function. A small plane is flying at a constant altitude of 5,000 meters directly towards an observer. Assume the ground is flat near the observer. Draw a diagram that represents the relation between the horizontal distance in meters from the observer to the plane and the angle in degrees formed by the vertical and the line of sight to the plane. Use the characteristics of the tangent function to describe what happens to the graph as the plane flies from the left of the observer to the right of the observer. Let's draw a diagram. We have a right triangle. The plane is up here. That's my plane. We have an observer down here. The plane is 5,000 meters up. We have the angle in degrees formed by the vertical and the line of sight to the plane. So between the vertical and the line of sight, that would be our angle theta. This is our horizontal distance. Which would be the side opposite. And then 5,000 would be our adjacent side. So tan of theta equals opposite over adjacent. Then tan of theta would equal, we'll call the horizontal distance d. So d over the adjacent side, which we know is 5,000. Let's draw a sketch of tan theta on this grid provided. Recall that our asymptotes occur at 90 degrees. We would also have one at -90 degrees. We have an X-intercept and a Y-intercept at the origin. Our tan function equals 1 at 45 degrees, and it equals -1 at -45 degrees. So we would have this image. We can relate this graph of y equals tan theta to the situation by saying that the x-axis represents the angle theta in the situation, and the y-axis is our horizontal distance. Then it says use the characteristics of the tangent function to describe what happens to the graph as the plane flies from left of the observer to the right of the observer. We can think of negative angles as this is on the left of the observer, this is where the observer is, and then this is on the right of the observer. So as the plane approaches the observer, the angle would get smaller, and the distance is approaching 0. Then when the plane is directly above the observer, the angle is 0 and the horizontal distance from the observer is 0. And then they pass the observer and head to the right. So now they're on the right side of the observer. And when that happens, as they move right, the angle gets bigger and the horizontal distance increases, but on the right side. So as the plane approaches the observer, the angle theta decreases, and the horizontal distance also decreases. When the plane is above the observer, theta and d both equal 0. Then as the plane moves away from the observer on the right, the angle theta and horizontal distance increase. That brings us to the end of Chapter 5, Lesson 3.